5 and the practice assignment also. And I have already informed in previous sessions. Once again, I am informing in this session also, and in every session. Okay, check your audio. Check your audio. 5:38. Check your audio. That's not my issue. Okay, so hello, Sandeep sir. Hello, Sandeep sir. My voice is audible. Share a screen. I hope you are all able to
Recording in progress.
view the screen. You are all able to view the screen and okay, fine. So we are going to see week 5 assignment. So can anyone confirm that you are able to view the screen? Yes, can anyone confirm that you are able to view the screen? Okay, thank you. So now this is okay, fine. So now this is week 5 assignment questions. So let's see one by one, and I will also explain the practice assignment questions also. And you have to go through all these video lectures, as in this week 5 they have given about optimization for data science. Optimization for a data science. So here multivariate optimization with equality constraints. So here they are going to discuss about the optimization with multivariate, in the sense more than one variable, that is nothing but a two variables, at least two variables with equality constraints. So in yesterday's session I have explained about what is an equality constraint and what is an inequality constraint. So equality constraint is nothing but this one, we can consider it as equality constraint, x square plus y square equal to 10. That means upon substituting any values of this x value and y value, definitely it will be equal to 10. So this is nothing but an equality constraint. This is nothing but an equality constraint. And where, so they have discussed the multivariate optimization with equality constraints in this video lecture. In the second video lecture, they have discussed about multivariate optimization with inequality constraints. Inequality constraints, in the sense, in inequality constraint, we can use less than, greater than, less than, equal to, greater than, equal to, not equal to. All these operations we can use in inequality constraint. So suppose for here, for the same constraint, if I say that x square plus y square less than 5, then that is nothing but an inequality constraint. It is not exactly equal to 5. below 5 it can be any value. Below 5 it can be any value, so that is nothing but an inequality constraint. And here they have given few examples that you know how to analyze the data and what are the problems can be identified while analyzing the data and all. And they have given here some sample data sets. So let's see that what are the questions given here. The first question, what they said, minimum the function minimum f of x comma y is equal to 3x plus y, subject to the given constraint, that is nothing but x square plus y square less than 10 is an example of. So here these are the options given. As I already told that this is an minimized function and the function is 3x plus y. What is the constraint? X square plus y square less than 10. So here two variables are included in the function. Two variables are included in the function. Those are x and y. So this is nothing but what? A multivariate, not an one variable. When it is an one variable, only f of x, then it is called it as an univariate. Okay, so when I say that univariate optimization with equality constraint, that means only one variable is involved in the function, right? So here x comma y, two variables are given, so then this is considered as an multivariate. This is considered as an multivariate. And if you look into the constraint x square plus y square less than 10, that means below 10 it can be considered. So if we use this less than symbol, what I said, this is considered as an inequality constraint. Sorry. So this is considered as an inequality constraint. So here the options are given. First option is what? Unconstrained multivariate optimization. That means what? Multivariate optimization means only more than one variable or at least two variables. The function is given and there is no constraint. That means there is no constraint. The constraint is not given like this, anything like that. Without any constraint, and this is the function, then in that case we consider it as an unconstrained multivariate optimization. But next is what? Multivariate optimization with equality constraint. Multivariate, yes, this here two variables are involved in this function, but equality constraint, no, because this is what? Not equal to x square plus y square equal to 10 is not mentioned. So that's why it is not an equality constraint. So that's why this option is also ruled out. Next, third one is what? Multivariate optimization with inequality constraint. So obviously here two variables are involved, so multivariate, and this is an inequality constraint where less than symbol is used. Because below 10 it can be considered. Below 10 is the constraint. Still below 10 it can be 10, it can be 9, it can be 8, or it can be 7, or it can be 6. So it's not exactly equal to. They have given and that less than or below 10. So that's why this for this question the answer is multivariate optimization with inequality constraint. I hope it is clear why these two options are not correct and why this option is correct. I hope it is clear. Yes? Is it clear? Yes, is it clear? Can anyone confirm? Or any doubt? Any doubt? Okay, it is clear. Okay. Okay, next. Second question is what? We intend to find the maxima of, right? We intend to find the maxima of f of x comma y equal to 3x plus y. This is the function given. This is the function given. Answer. 1 minute, students. We are checking the volume. Wait. Now is it, now is the volume is okay? Now voice is clearly audible or manageable? కిందకి రండి ఇక్కడ. Still low. Hmm. Okay, sir. Now the volume is fine. Manageable. అంతే. Full పెట్టండి. Now fine, better. అది లూజ్ కనెక్షన్ ఉంది సార్. చేశాను నేను ఇందాక. ఓకే. Yes, fine. So, various optimization problems in the sense, that's what I told. Unconstrained multivariate optimization with equality constraint, multivariate optimization with inequality constraint, with, with inequality constraints. So here you can check in week 4. That is the optimization. What do you mean by unconstrained multivariate optimization? And here you can see, go through the gradient and all. So now I have told that without any constraint, this is without any constraint. That means the constraint is not given, only this function is given. That means it is an unconstrained multivariate optimization, but constraint is specified, so this is not correct. Here equality, not, this is not an equality constraint, because it is not equal to 10 or equal to 9 or equal to 8. And whereas this is an inequality, for inequality we use the symbols, whatever I said, less than, greater than, or equal to, not equal to, like that, right? So now here, second question, we intend to find the maxima of function 3x plus y subject to the given constraint x square plus y square equal to 10. Right? So now what they are asking, what is the Lagrangian function? Right? What is the Lagrangian function? So how you are going to write with this objective function and with respect to the given constraint, with respect to the given constraint. So here you can check it out, this one. So whenever it is asked like that, subject to the given constraint, so the Lagrangian function is modified version of the objective function with the constraints incorporated. So how you are going to write the Lagrangian function? So this is the format. This is the format here. So L is represented as an Lagrangian function of x comma y comma lambda. So x y are nothing but the variables involved in the objective function, involved in the function, and the lambda here. So here for this one, what you will write, Lagrangian function equal to f of x comma y, that is nothing but this function, and plus lambda of, and this is an c constant, this is an a c minus g of x comma y, that is nothing but the constraint. So g of x comma y, that is nothing but the constraint what is given in the problem, and here c is nothing but the constant here 10, right? So now this is the format we use to write the Lagrangian function. So in that case here, L of x comma y comma lambda, and what is the f of x comma y is given here, it is 3x plus y, it is 3x plus y plus lambda, What is C here? Constant 10. So 10 minus g of x comma y. G of x comma y is what? X square plus y square. That means 10 minus in brackets x square plus y square. So that becomes what? 10 minus x square minus y square. So this is how we write the Lagrangian function for the objective function with respect to the given constraint. With respect to the given constraint. So that's what here, this is the correct option, because this is not the form, this is not the correct one how we write, and this is also not correct one, and here this is the correct one, because f of x comma y plus lambda into c minus g of x comma y. And what is the whatever the format we got here, so this is how we represent in Lagrangian function, right? So that's why this option is correct. Now this option is correct. Next is what? The third question. The values of the stationary points. The values of the stationary points, right? And here, if you have, yes, less than equal to is also nothing but inequality constraint. That's what I told. Only when it is the when x square plus y square is equal to 10, then only it is considered as equality constraint. If less than, greater than, less than equal to, or greater than equal to, or not equal to, in that case we consider it as an inequality constraint. We consider it as an inequality constraint. Okay, so that's what less than equal to 10 means, we will consider it as an uh, inequality constraint, because it's not specifying that exactly equal to this value, the constant value. So less than equal to 10 means what? Below 10, or below 10, or equal to less than equal to 10 means including 10 and below 10, right? So that is also considered as inequality constraint. That is also considered as an inequality constraint, right? So now, so this is what the Lagrangian function format. So how we write this function? So using this representation or the format, if the question is asked like this, then using this format you have to write like this, and then check for the answer, check for the answer whether it is correct or not. Only in this question is that if you know this format, that how we write the Lagrangian function, then it is easy to write, it is easy to get the answer. It is easy to get the answer. F of x comma y is this, plus lambda of c is the constant. So here this is the constant value, and g of x comma y is the constraint what it has given, x square. So if it is given like this is considered as an equality constraint. This is considered as an equality constraint, right? I hope second question is clear. Right, next see the third question. Next see the third question. So now what is the question asked? Find the values of the stationary points. Find the values of the stationary points x star, y star, and lambda star for the given objective function, that is f of x comma y equal to 3x plus y, subject to the given constraint, that is x square plus y square minus 10 equal to 0, right? So here objective function is given and the constraint is also given. That constraint is nothing but g of x comma y. So now what they asked, find out the stationary points of for x star, y star, and lambda star. Now how we will do that? Let's see this. Now how we will do that? So let's see the answer. Let's see the answer for this, right? So now here for the third question, first what I have to do? So here if you need to remember that when lambda is given, you might have confused with In the previous assignment also we have solved the question called find the stationary points for the given objective function and all. So in that question lambda is not there, lambda is not mentioned to find out, right? So that question and this question don't get confused. So here they ask to find out x star, y star and lambda star. These are the stationary points. When lambda is mentioned here, obviously we need to use an Lagrangian function for the objective function. So that is nothing but the modified version of the objective function is Lagrangian function, right? So now what it is, L of x comma y comma lambda equal to f of x comma y plus lambda of c minus g of x comma y, c minus g of x comma y. So when I say that c minus g of x comma y, then this one c is the value this one and g of x comma y is this one. So we are going to just substitute those functions, the constraint in that format, and then you will get what, 3x plus y plus lambda of x square plus y square minus 10 equal to 0. This is what the simply Lagrangian function format, and consider this as an equation 1. Consider this as an equation 1. Now, so here with respect to x, the first derivative dou L by dou L by dou x with respect to the first derivative. So here this is the first derivative with respect to x, first derivative with respect to x. That means from this function you need to write the first derivative with respect to x, with respect to x. So that means what here with respect to x means, so now here the first derivative, if you consider this one f of x comma y is the function, objective function, 3x plus y is the objective function. What will be the first derivative we will get with respect to x? Only 3 we will get, only 3 we will get. And now here what is the first derivative with respect to the constraint? Here we will get with respect to x, we will get what, 2x, we will get what, 2x. So 2x into lambda. So that's why here with respect to x the derivative 3 plus 2 into, that means x square is what, the first derivative. So 2x we will get. Here the first derivative with respect to y we will get 2y, we will get 2y. So now here 3x means 3 we will get with respect to x plus 2 into lambda x. This is 2x into lambda, that is 2 lambda x equal to 0. And then what we will get, you have to find out that the lambda value. So here the lambda value is nothing but what, you know what, like how to bring this equation left hand side or right hand side, right? So here 3, if it comes this side, then minus 3 by 2x. So lambda equal to minus 3 by 2x. Anyway, you have done this kind of maths in high school, right? Similarly, the first derivative with respect to y, the first derivative with respect to y. So now check here with respect to y, then this becomes 1 in first derivative, 1 plus, so y square is what, 2y, it becomes 2y, 2 into 1 and y, so 2y into lambda, so 2 lambda y equal to 0, y equal to 0. So now what, from this when you evaluate, then we will get lambda equal to minus 1 by 2y, lambda equal to minus 1 by 2y. So consider this as equation 2 and consider this as equation 3. So from these two equations, that means what here, from these two equations, lambda is equal to what, minus 3 by 2x equal to minus 1 by 2y equal to lambda, right? So now here when you just see this, x equal to minus 3 by 2 lambda, y equal to minus 1 by 2 lambda. This is nothing difficult. Only the thing is that the first derivative Lagrangian function is written, in the required format. Then after that, the first derivative with respect to x from objective function and from the constraint. And then this is the first derivative with respect to y from objective function and as well as from constraint. Then lambda value is, lambda value, we got this value as a lambda value, and then this is also lambda value. So considering these two equations, so this is equal to this. So what we got, what x equal to minus 3 by 2 lambda, y equal to minus 1 by 2 lambda. Now what is the condition given here? What is the condition given here? X square plus y square minus 10 equal to 0. What is the x value here? We got minus 3 by 2 lambda. So minus 3 by 2 lambda whole square plus y square is what? Minus 1 by 2 lambda. So minus 1 by 2 lambda whole square equal minus 10. If it comes this side, it becomes plus 10, right? So now upon square, what we will get? 9 by 4 lambda square plus 1 by 4 lambda square. Anyway, this is whole square, so this becomes positive, right? So now what we will get? 10 by 4 lambda square equal to 10. So 4 lambda square equal to 10 divided by 10, that becomes 1 lambda square equal to 1 by 4. Lambda square equal to 1 by 4. So now what we will get? Lambda square equal to 1 by 4 means this is what? Square root of it. This is what? Square root of it. So lambda equal to plus or minus half. That plus or minus half is nothing but what? Lambda equal to plus or minus 0.5. Plus or minus 0.5, right? So now what we have to do? We got the lambda value as plus or minus 0.5 because lambda square equal to 1 by 4, lambda equal to this. So now once we got the lambda value, so plus or minus 0.5 means it can be considered as 0.05 and also negative 0.5. So now what we have to do? Now what we have to do? We have to substitute the lambda value to find out the x value. That is what? X equal to minus 3 by 2 lambda minus 3 by 2 into 0.5. So which is equal to what? Minus 3, which is equal to what? The minus 3. So anyway, if we substitute the negative value here, this becomes positive. So we will get what? Plus or minus 3. Similarly, what we got? Similarly, we need to find out the value of y. So if lambda equal to 0.5, y equal to what? Minus 1 by 2 into 0.5. So this becomes minus 1. With the negative value, we'll get plus 1. So x value is plus or minus 1. Sorry, y value is plus or minus 1, x value is plus or minus 3, and lambda value is plus or minus 0.5. So this is how you will get the values here. This is how you will get the values here to find out. So the same procedure you need to follow. The same procedure you can adopt. Anyway, this is all completely mathematics. So solving the finding the values and solving the equations and all, you have already studied in school itself only, right? Is this question is clear? Yes, solution is clear. Okay, ma. Right? So solution is clear. Right, next question. Let's see the next question. Next question, what it says. Same question actually. Same question. The values of the stationary points, that is x star, y star and lambda star for the objective function. So here the function is different with respect to the given constraint, that is what? X square plus y square equal to 136. So we follow the same approach. We follow the same approach because the question is same. Function is different. Function is different and constraint is different, right? So first what we need to do? We need to write an Lagrangian function in that format, in the required format. Then the first derivative with respect to x, then the first derivative with respect to y, right? So here if you observe, 5x minus 3y is the function and this is an constraint, x square plus y square minus 136, right? So now first derivative with respect to x, so here we will get 5 plus x square is what? 2x in first derivative, so 2 lambda x equal to 0. Now, similarly, the first derivative with respect to y in this objective function, we will get what? Minus 3. We will get what? The minus 3 plus y square is what in first derivative? 2y we will get. So, 2 lambda y is equal to 0, is equal to 0. Now 5 plus 2 lambda x equal to 0, then upon evaluating what, simplifying, just simplifying, what we will get, lambda equal to minus 5 by 2x, lambda equal to minus 5 by 2x. Similarly, here we will get lambda equal to, this minus 3 comes this side, so it becomes plus. So 3 by 2y, 3 by 2y, right? So then what it is here, then this is an equation to equation 3. So simply what? Minus 5 by 2x equal to 3 by 2y equal to lambda. So x becomes minus 5 by 2x, y equal to 3 by 3 by 2 lambda, and here minus 5 by 2 lambda, right? Now substitute the x value and y value in the given constraint, that is x square plus y square equal to 136. So now in x place we will substitute minus 5 by 2 lambda whole square, plus in y place we will substitute 3 by 2 lambda whole square equal to 136. Upon square we will get these values. So obviously what, 34 by 4 lambda square equal to 136. So lambda equal to lambda square equal to what? We will get 1 by 16. So lambda is nothing but what? Here plus or minus 1 by 4. This 1 by 4 we can return it as 0.25, 0.25. So now we got the lambda value plus or minus 0.25. Now what we have to do, substitute the lambda value in for the x value, to find out the x value, and here also to find out the y value, to find out the y value. So lambda equal to 0.25 and minus 0.25, then x equal to what? Minus 5 by 2 into 0.25. So we will get what here? Minus 5 by 0.5. So here we will get plus or minus 10. Similarly, if you substitute here 3 by 2 into 0.25, so here we will get plus or minus 6. So the same procedure, function and the constraints are different. So what you have to do, if the question is asked like this, to find out the stationary points x star, y star and lambda star for the given objective function with respect to the constraint, then you have to write the objective function and the constraint in Lagrangian function format, then find the first derivative with respect to x and first derivative with respect to y, and then you'll get lambda value. Then upon equality, assuming that lambda is not equal to 0, upon this, then you'll simplify it for the x and for the y and substitute this xy values in the given constraint. You will get lambda value, then substitute this lambda value to find out the x value and to find out the y value. Then finally what we got, lambda equal to plus or minus 0.25, x equal to plus or minus 10, y equal to plus or minus 6. So that is what the answer given here, x equal to plus or minus 10, y star equal to plus or minus 6, and lambda star equal to plus or minus 0.25, plus or minus 0.25. Is this clear? Yes? Is this clear? The same procedure, same question given with the different values, same procedure. Right? Okay. So now, what is the next question? So next question, what it is given? The Hessian matrix for the function. So that means you have to write a Hessian matrix for the given function. That is what, f of x comma y equal to minus 5x square plus 4xy plus 3y square plus 2x minus y, plus 2x minus y. So here you can see this. So here you can see this. So how do you represent the Hessian matrix if the function is given? How do you represent the Hessian matrix if the function is given? So now the Hessian matrix is what? Dou square f by dou x square. That is nothing but what? The second derivative of the objective function. Then dou square f by dou x dou y, and here dou square f by dou y dou x, and here dou square f by dou y square. So all are second derivatives for two variables x comma y. Now what is the function given here? Minus 5x square plus 4xy plus 3y square plus 2x minus y. 2x minus y, right? So understand this carefully, actually understand this carefully. Now the from this function we are going to write the first derivative with respect to x, in the first derivative with respect to x. So here minus 5x square, so minus 5 into 2 it becomes minus 10, so minus 10 into x plus, so here 4xy is given, so x will be, x will, we will make it as 1 here, so x we will make it as 1 here, so we will get 4y plus this is y, but we are saying with respect to x, so this is also not considered, but here x is there, so plus 2x will become plus 2 and here minus y, right? So first derivative with respect to x, so here this we will get minus 5 into 2 minus 10 into x plus, so here x becomes 1, so now here what, 4 into y, 4y plus here no x, but here x is there, so plus 2x it becomes plus 2, right? Now what about the second derivative from this first derivative? From the first derivative, what will be the second derivative? Dou square f by dou x square, so here we will get only with respect to x, we will get only minus 10, we will get only minus 10. Now come to this dou f by dou y, that is the first derivative with respect to y, first derivative with respect to y, anyway this becomes nothing, this we don't consider it, and here y becomes 1, so we will get 4x and 3y square, obviously 3 into 2 6, 6y, and here y is not there, so here minus y, so this considered as minus 1 in the first derivative, so 4x plus 6y minus 1. Now from this first derivative, what is going to be the second derivative? With respect to y, with respect to y we will get only 6, we will get only 6, right? So second derivative with respect to x, that is dou square f by dou x square equal to minus 10, and here dou square f by dou y square equal to 6, right? Now what they said, dou square f by dou x dou y equal to dou square f by dou y dou x, which is equal to what? Simply take it out of dou by dou x of dou f by dou y, right? So this is nothing but what here, this is nothing but what here, you consider it as an a 4 here, right? So dou by dou x of dou f by, anyway dou square f by dou x dou y, right? So dou x dou y means what, here we will get a 4, and similarly dou square f by dou y dou x also, what we will get here, 4 only, 4 only, so that's why this is 4. So now in this form, in this matrix form, we need to write what we got, dou square f by dou x square minus 10, dou square f by dou x dou y, with respect to this we will get 4, and similarly dou square f by dou y dou x with respect to this we will get what, 4 here. So most of the times this will be same, most of the time this will be same, this will be same. So now dou square f by dou y square, what we got, we got 6 value here, we got 6 value here. So writing in Hessian matrix form, the what is the matrix, minus 10 4 4 6. So that is how we got the answer here, the Hessian matrix for the given function, and this is the matrix we got. So this is the correct answer. Now for this matrix, for the Hessian matrix, find the eigenvalues, find the eigenvalues. Now if you remember in previous session I have explained that how to find out the eigenvalues for the given matrix in RStudio using R code, in RStudio using R code, right? We have an eigen function, then how to find out the values and all with the help of the R code. Now I will explain manually to find out the eigenvalues, because in exam you will not be able to you will not be having a facility to use the R studio and all. That time you have to find out manually only. That time you have to find out manually. So that's why you should know that procedure, and as well as you should know the manual procedure also, right? Is this clear how we got Hessian matrix and all concept again? Okay, fine. 563. Okay, fine. I will explain once again, right? Now, this is what Hessian matrix. How we write the Hessian matrix? The matrix form is like this: dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, and dou square f by dou y dou square f by dou y square. So this means what here? So we have like the first second derivative for the given equation, for the given function. In school itself only we have studied how to find out the first derivative, and how to, from the first derivative, how you find out the second derivative, how you find out the second derivative. So now what is the equation given here? Minus 5x square plus 4xy plus 3y square plus 2x minus y. Now from this equation, find out the first derivative with respect to x. Find out the first derivative with respect to x. So you know, from this here minus 5x square, this becomes minus 5 into 2 into x. So minus 10x plus, so here x becomes 1. So 4 into y, 4y plus, here x is not there. So with respect to x plus 2x, so x becomes 1. So plus 2, plus 2. So in first derivative with respect to x, we got minus 10x plus 4y plus 2. Now from this first derivative equation, we need to find out the second derivative with respect to x. Then what we will get? We will get minus 10, and all this becomes not considered, 0. Now come to this. So this is what the first derivative with respect to y. First derivative, so here y is not there, so here it is there, y becomes 1, so we will get plus 4x. Now 3y square becomes 2y, so now 3 into 2y plus 6y. Then here here we will not consider this one, minus y is nothing but becomes minus 1. So for the first, from this equation, the first derivative with respect to y, we got this value. Now from this equation, we have to find out the second derivative with respect to y. Then we will get only this 6 into 1, so that is 6. So this and this we will not consider. I think up to this it is clear, right? Now what they are saying next, dou square f by dou x into dou y, or dou square f by dou y into dou x, That means what here? This means, so here second derivative with respect to x, second derivative with respect to y, right? So like this, second derivative with respect to y, we will get 4. Second derivative with respect to x, we will get 4. So that's why we considered it as an, this one and this one both are 4, Now what are the values we got here? Dou square f by dou x square, we got minus 10, so that's why here we have written minus 10. Dou square f by dou x into dou y, what we got here? 4, so 4 is written here. Dou square f by dou y into dou x, what we got here? 4, so 4 is written here. Dou square f by dou y square, what we got here? 6, so 6 is written here. This is what the Hessian matrix. Is it clear now? Yes, 563. Now understood? Okay. Right? So now what they asked, from this Hessian matrix got in question 5 answer, find out the eigenvalues. Now how we can find out the eigenvalues? So here you can observe this. eigenvalues of this is the format we represent, or we are going to represent in this format to find out the eigenvalues. That is what a minus lambda into I, a minus lambda into I here. So now what, this is an a matrix, this is an matrix, assume that this is a, assume that this is a. So now what it is, a minus lambda into a minus lambda, not into, a minus lambda, and here space I. So now I is nothing but what, identity, it will be same, the diagonals will be same, the diagonals will be same here. So now what it is here, minus 10, so for the matrix here, so minus 10 a here, minus lambda, minus 10 minus lambda. And here what are the diagonal values we got here, the same identity. So 4 we got here, 4, and here also 4, that is nothing but what here, a minus lambda I a minus lambda, I a minus lambda. So identity same here, we got the values. So now 4, and here also 4 is returned, and here also once again what, a minus lambda, so 6 minus lambda, 6 minus lambda. So how do we get the characteristic equation? Now multiply the diagonals and subtract it, multiply the diagonals and subtract it. So now characteristic equation is what? Multiply the diagonals and subtract. Now minus 10 minus lambda into 6 minus lambda, right? Minus 4 into 4, 16 is equal to 0, right? So multiply this diagonal minus multiply this diagonal. So that is equal to 0. So minus 10 minus lambda into 6 minus lambda, you multiply these two, multiply these two, then what we will get, lambda square plus 4 lambda minus 60 minus 16. So multiplying these two, we will get lambda square plus 4 lambda minus 60, then minus 16 equal to 0. So finally what we'll get, lambda square plus 4 lambda and minus 76 we will get. Now this is an characteristic equation, ax square plus bx plus c equal to 0. As I already told you that roots formula, find out the roots formula, that is minus b plus r minus root of b square minus 4ac divided by 2a, divided by 2a. So using that formula you substitute the values. So here you substitute the values here. So lambda, so here, so lambda equal to what here, the minus b plus r minus root of b square, right? So like that, you here the b is what here, 4, so minus b plus r minus root of b square is 16 minus 4ac, minus 4ac means minus 4 into 1 into minus 76, that's what we will get, divided by 2a, that is 2 into 1. Now evaluate it, evaluate it. Now find out the root of 320 value, 320 value, then minus 4 plus, that means minus 4 minus whatever the square root value we will get, divided by 2, then minus 4 plus whatever the root value divided by 2, then we will get two values, that is lambda equal to this and lambda equal to this. So that is what we got here, minus 10.944272 and this one. Now you have a doubt, you have a doubt that no, because exam time is for 3 hours, and if we just calculate it, then it takes time. So that's why a online calculator, only online calculator will be provided. So how to use that online calculator during the external exam, during the external exam, in announcements they have given, in announcements in the exam format they have given here, on screen calculator demo link. Go through this link and listen to the demo, and then understand that how we can use the calculator during the external exam, during the external exam. And this is going to be an computer based test, so it is very important that go through all these things, then you will understand. So only the on screen calculator will be provided, you will not have a facility of RStudio or R console. You will not have a facility of RStudio or R console. Okay. So now, right now, is this clear? How to find out the eigenvalues for the given matrix? Is this clear? Right? Okay, fine. So next, what is the last question? So here it says, this is an theoretical question, a predictive modeling problem. A predictive modeling problem. If a predictive modeling problem is given where the class label is predicted for the input data is type of classification problem. Is type of classification problem. If you go through this video about a predictive modeling, then you will understand that why it is a type of classification problem. So predictive modeling problem is given where the class label is predicted for the input as a type of classification problem, right? And now week 5 practice assignment is given. Now week 5 practice assignment is given. Now this is simple, f of x bar. This is nothing but what? Objective function. This is nothing but what? Objective function. And h of x bar equal to 0. This is nothing but what? Equality constraint. This is nothing but what? Equality constraint. And this one same. Consider the multivariate function and the values of x1, x2 and lambda from the first order necessary condition. That means from this, in anyway in next class I will explain, because for this the procedure is different. For this the procedure is different. So here you need to understand. I will solve and show it to you that how you get the values, but not like using a Lagrangian function and all, because here it is given multivariate function minimum x1 x2 f of x. Then find out the values of x1 x2 and lambda with respect to the first order necessary condition. First order necessary condition means here with the first derivative. So from this given equation, find out the first derivative. From the first derivative, you find out the values of x1, x2 and lambda. x1, x2 and lambda. So here this one I will explain in the next class to understand, because this is procedure is somewhat bit different in the sense how do you denote the dou f and then dou h and all. Then I will solve and show it to you, this question, third question. And now here, if the objective function f of x bar is a quadratic function, that means objective function is a quadratic function, and the constraints are linear, then the type of optimization problem is quadratic programming. I already told you in the yesterday's session that in week 4 assignment the question is given objective function, equality constraint and inequality constraint all are linear, then what is the type of optimization problem? Then I told that it is an linear problem. If it is an objective function is a quadratic function and the constraints are linear, then it is going to be an quadratic problem. So that's why here the question is given quadratic function and the constraints are linear, then we consider it as an quadratic programming. Is this clear? Right? So in next session I will explain about this question, that how do you solve it to get the x1 value, x2 value and lambda value, x1 value and x2 value and lambda value, right? Is this clear?